Hello, it's June 27th, 2023. It's a SIG Node weekly meeting. Welcome, everybody. We have low attendance today and not many topics, so let's jump right in. I think Mahmed said that he'll be 5 minutes late. We will leave this topic for later. Let's go to the second topic. Vedsan, is Vedsan on the call?
Yes, hi, I'm here. Can you hear me?
Yeah, loud and clear.
Let me try to enable my video here. Yes, hi. So I'm going to paste here. I opened the pull request. So by the way, this is my first meeting. I work with Microsoft, and we are working on these confidential pods on Azure Kubernetes, basically. And I opened this PR as an example, right? Of course, we don't need this to be the solution, just a proposal. So the problem we are running into is that we'd like to be able to run different runtime classes on the same Kubernetes cluster. And we've run into a problem when we have different snapshotters. So we use Containerd. Containerd now allows different snapshotters to be used per runtime class. And then we run into this problem where when we run a confidential pod first using an image, and then you try to run another non-confidential pod later using the same image, it fails to start because it thinks that the image is already present. And the image is only present in the snapshotter of the confidential pod, not on the other snapshotters like overlayFS snapshotters. And then thanks for pasting the PR there. So one way that we found to address this issue is to add an annotation to the image reference when we are about to pull image, or we want to check if an image is present or not. And this needs to come from well, it doesn't need to come from the kubelet, but if it comes from the kubelet, it's automatic and doesn't require users to annotate their pod YAMLs. So we can go into more details of the problems we're running into, and I try to describe them in the pull request. But the request to kubelet is basically to add an annotation, and this is sort of what the pull request does. So what I'd like to hear from you is how do you feel about this? Do you have perhaps other things that come to mind to try to address this sort of problems, or any feedback on addressing the problem or the pull request? Either one.
Team Mike Brown turned on video, meaning that he wants to comment on that. And I think I know what the comment will be, but go ahead.
Yeah, no, this is fine. Using an annotation would be a good way, I believe, to align for a particular runtime handler. But yeah, what we'd like to do is eventually pass the policy for doing the ensure down to the container runtime, as opposed to having kubelet do the ensure first and then run the pod. By the way, well, I don't know if you noticed, but the pod itself also, for each container, will ensure that image is local. And depending on whether you've got isolation across the various runtime engines and snapshotters, we may or may not be able to share some information, since they're both in the K8s.io namespace. We might actually be able to allow certain things to be shared across like snapshots. Right.
Yeah.
Definitely an interesting topic. We'd like to work with you a little bit more on this. Maybe a call with Derek McGowan, myself, and a few others. Peter Hunt, I think, on the image side in Cryo as well, I think, to make sure this is aligned. But I do like the idea of adding an annotation, at least for now, for aligning what's going to be. Tell us what runtime handler you're going to use, So we'll pull to that space and ensure that space when they're requesting status on the images. You
Yes.
need both. Yeah. You can't just say pull, please go pull this to that runtime handler. You also have to say, when you're getting the list of images and the status for all of them, you actually have to say that as well. And we don't have an aggregation idea yet across that. Now, confidential containers may not even want to share what they've already pulled. So this is it might get tricky in how much isolation they're requesting.
Right. Yeah. I actually didn't know that you were planning to push the policy into the CRI servers.
Well, that's a long-term plan, is to move to policy handling on that kind of thing. Because it's not working very well to have Kubelet managing that policy without our understanding of it. And then we have two types of garbage collection, one for the image reference and the other for the snapshots. Okay. So it's a little crazy right now. Yeah,
sounds good. I mean, in terms of additional discussions and meetings, let me know when you'd like to do it. Happy to be part of it.
It's also gonna be cross-related to a KEP we've got called ensure pull policy, or ensure pull always. Kind of, I don't know if you know the image policies where it's pull always or pull if not present. You got the same kind of problem there. If it's there for one, is it there for both? We've already got some code going in for that. And it won't understand your annotations.
Right.
When you do annotations, I have looked at PR. Do we do anything special for garbage collections that Kubelet will be doing? Like, will Kubelet recognize that it needs to collect garbage for both runtime classes? Would it even know about
That's just it, Sergi. Do we want Kubelet to aggregate across all of the runtime handler namespaces within the KS.io namespace? Maybe, maybe not. I don't know. When you're asking for ensure, do we, that's a tricky question. We could just reply back to you, Sergi, which snapshot are we using? But again, that's only for Container D. It's not for Cryo yet. They're still using the graph driver. They're not using this kind of concept yet.
Yeah. So in terms of the PR, I'm not touching anything related to garbage collection of images. I'm just adding the annotations in the ensure image exists, and then so this gets translated into the annotation into pull and the check for the presence. Right, that's really all I'm doing, and there it's the annotation for the runtime handler, right? So we don't actually mention the concept of snapshotters. This gets used in the Container D case based on the runtime handler.
Okay.
So we will eliminate problem of pod cannot start because image mistakenly was recognized as existing. But we will introduce another problem of some images.
It'll still work, Sergi. We'll just ensure late. If Kubelet thinks it's okay to run the pod because the image is there, they're trying to make sure they can get the images down, right? But then when you actually run the container, we also ensure it again one last time because it could have been collected, right? Between you actually asking the question and it happening, we check one more time. And which isn't a big deal if it's cache local. It would only be a big deal in the case of Weldon's case here where they needed it to be in another snapshot.
Yeah, but the question I'm trying to ask: do we introduce another problem with images being stuck forever and never garbage collected in some snapshotters? Do we need to fixing one problem and introducing another may not be ideal. And if we have any mitigation, it will be great.
Also, the being able to configure this snapshot per runtime handler is more of a new thing, and it's only in 2.0. I don't think we really expected it to be used a lot yet. So, yeah, some work needs to be done here.
Something to think about, a strategy that could be used.
Absolutely, yeah. Hey, Peter.
Hey, something to think about. Also, a strategy that could be used is in situations where the image is stored in a different runtime handler than the default. We could use the CRI pinned field and then have the runtime handle the garbage collection of those images instead of have the kubelet do it. So it would just be basically considered a totally separate, like the kubelet wouldn't consider it for eviction.
So they would,
so
we'd be in charge of evicting those. That's actually a good idea, Peter, for a way to transition to a policy here. Because right now, pending is the only policy we have, right?
Yeah, it's the only way for the CRI to tell the kubelet to like tune its eviction. The other thing is, we brought this up a couple of weeks ago, but in 129, we're going to be collecting use cases for like a more clever image eviction schemes. So like this is a good thing to bring up now, so we can consider that in, as we go forward with kind of figuring out different ways to, tune that.
Sure.
Peter, can you comment on this issue? Mrunal mentions that it may be related, and it's I think it's in cryo as well. So do you know?
So this is different. This does have to do with like the CRI needing to know more about like image lifecycle than the kubelet is currently giving it. But this is more specifically like where this is for cryo is trying to add support for using SIG signatures and verifying with those. And we're trying to make it namespace aware. Because the kubelet only pulls image once, for the whole node, it's not aware of like whether or not it can, like if a container A did have the signature or it was in the namespace with the signature policy correct, then it would be able to pull the image. But then if container B wasn't in that, then it would, it should not be able to, but it is currently able to rely on the fact that container A had already pulled it. So it is related in that like currently the kubelet doesn't try to verify a container should be pulled for each container. An image should be pulled for each container that it's running for. It just does it once for the node, then verifies that it's still present for the node. So it is relevant to the degree that currently the kubelet doesn't know enough or isn't expressive enough for all of the different like image storing or pulling mechanisms that the CRIs are trying to work through right now.
You're talking about here artifacts specifically for signed artifacts pointing to the manifest
well,
that requested us to pull.
So yeah, I mean that's more digging into the weeds, but like generally the idea is like verifying signatures on a per container basis as opposed to a per node basis. So like certain namespaces could have different providers for signatures, and but right now it's only defined per node. So the kubelet's only able to the CRI is only going to pull an image once, and at that point we'll verify the signature for whatever container it's being pulled for, but it won't actually do it for each future container.
It really depends what the signature is pointing to, right? On who should be doing that. If it's, we don't have a way to reply back, Sergey, to kubelet right now, a list of signatures on all of various blobs manifests that we pulled from this image that you've requested. It's not in the status yet, right? But I guess that's the question, Peter. What should we be doing this kind of policy management to make sure these things are signed down in the container runtimes? I think so. Or do we keep letting kubelet or keep requiring kubelet to do the management of those types of things, artifacts, making sure it's got an SBOM, that sort of thing, right? Upper level, or is that lower level? Yeah.
It's better to do in low layers because it's implementation detail for each runtime handler.
Yeah.
Yeah, I mean, this is going back to the classic philosophical question that SIG Node has been grappling with for a while. Like, who is the entity that is aware of the pod lifecycle, and who is the entity that needs to react to the pod lifecycle? Like, currently the kubelet is the one that's aware, and the CRI is, reacting, but we're in the process of like pulling things down to the CRI to be the one to be aware. If if we did move the entire pod creation process, without having the individual steps be micromanaged by the kubelet. If we move that all down to the CRI, then we'd be able to handle this natively just in the CRI. But because we don't do that, we have to kind of jump through these hoops like this right now.
Okay. Interesting discussion.
So specifically for this PR, I think we may need to get more information of like what alternative we have. Maybe we can introduce some new CRI field and it will solve this. And plus trying to address the problem of garbage collection. So introducing new problem while solving other problem, it's not ideal. So we need to, Betson, do you have enough action items from this discussion?
I'm trying to understand better understand the lifetime issues, the image lifetime issues from as far as I understand, what like sort of the implication of this is that if you have, let's say, some image that was downloaded for two different runtime handlers, right? Then my understanding, and then only one is being used, and the other one's not being used anymore. Then neither would be garbage collected. But then once they're both gone, then both would be eventually would be garbage collected.
That's right. This requires when you do a pull or an ensure process that you at least pass in the runtime handler that's specified for the pod. And then internally, when we reply back to a list, we need to return the handler that was used if we decide that's the right place to handle ensure for this kind of thing and for signatures and other stuff.
Yes, but then what I'm trying to say is that when we report the list, for example, we don't do filtering. So if on the list, we actually get the list regardless of which runtime handler has it, right? Then I think garbage collection still works, but that has this quirk where you would only garbage collect the thing once all of them are gone, right? So what I'm trying to understand from you is,
and you say kubelet needs to know about the option now. So you'd have to have two lists, one for each, or if you had two runtimes, you need two lists.
Yes. So my question to the room is, do we actually need to do that, or would it be acceptable to garbage collect all of them once all the users are gone, or do we actually need to garbage collect like individual handlers, right?
Well, you can. I guess it comes to like how long you want the duplicated images to be stored, because like you can pretty much consider it like two containers on the same node using the same runtime class. Like, that's what the kubelet will consider it as. The problem is the underlying storage layer, the image will be duplicated between the two spots. So it's like, do we find that duplication acceptable, for the number of images that would be used between both? Like, coming to think of it, I think that at this point that is acceptable versus needing to teach the kubelet how to be aware of these two things, because this is kind of like, it's a niche use case. I mean, it's not super niche, but it's a pretty fine-tuned use case. I don't imagine that there are that many pods or nodes even that will be running both confidential computer, containers and conventional ones using the same exact images. So like in practice, the duplication, I don't see it happening that much, even though it's theoretically possible. So like, my gut feeling is it's acceptable to have that duplication while both either one of the containers and either one of the runtimes is still running until both of them go and the GC starts kicking in. So like, I agree with you. I think that it does seem like that's acceptable for now.
Do we know, Mike, do you know if you delete image from container D, will it delete from both handlers or it will just delete from default? Because my comment was in assumption that container D may have this behavior when it will try to delete only one, and you will get stuck in a situation when container D always returns the image, kubelet tries to delete it, and it always tries to delete from default, and it never got deleted.
Oh, so just an interjection there, just briefly. Sorry for speaking over people, but this is actually a point of discussion and something that I sort of mentioned on the PR, right? We have a choice on what to do when the annotation is not present, right? So when the annotation is not present on list, for example, we can list everything regardless, or even on remove. We can remove all instances regardless of where they are, in which handler they are. And if the annotation is present, then we only do that action to that specific handler. With an approach like this, then things like cry cuddle RMI-A, for example, removes everything, right? And in fact, I've played with if annotation is not present, we go to the default runtime handler instead of using any runtime handler. And in that case, we run into this problem of like getting images stuck because we're never specifying the right runtime handler for that image. So I think this like the default action when annotation is not present sort of like helps addressing this concern.
Okay.
So when you call RMI,
Yeah,
it will delete it from all handlers?
Yeah. Yes.
Okay.
Yeah, I think that makes sense. I think that like, yeah, establishing in the CRI that if your image is duplicated between multiple handlers, then like the kubelet asking to remove it, that should apply everywhere because the kubelet's keeping track of which containers are using what.
Until
So
such time as we come up with a deleted from one place only. Yeah.
Right, until we teach the kubelet how to do that or move it all down to the CRI. Yeah, in the meantime, basically, make sure that it's removed everywhere when it's requested to be removed at all.
Right. And then on the other side, we remove the snapshots when there's no more references. So we're good on that side too. Okay.
Let's discuss the rest in NPR.
Sounds like a plan.
So, so let me try to understand the conclusion here. Is there anything from me, or do you feel that this might work, the annotation thing? Are there any concerns, things you'd like me to do? How do you folks?
No, I think this is going to work well. Generally, we're only going to collect these images when there's pressure. So I just need to test that, right? That it's deleted from all places expected.
I actually think this might be a hotter take, but I actually think we don't need your PR as it stands as long as containerd or the CRI is doing the correct thing with the removals, because it was mentioned earlier that like at container run time, if the image is not present, at least container like CRI doesn't have this behavior yet. So I'm going to speak.
It will require a doubling of the images though, and uncompress as well, right? So.
Oh, so the issue is basically that it would be duplicated all the time rather than only when it's used in both. Okay, yeah, then your PR makes sense to me.
I'd have to check and verify, Peter, that we're not just
No,
uncompressed, but I believe that's the case. Yeah, I'll check.
Yeah, no, that makes sense. That it would if containerd wasn't being told to pull anywhere specifically, it would just pull to the default. So yeah, that makes sense.
By the way,
I'd like to at least add, which runtime handle, even if we're not going to use it, I'd like to be able to see when they request an image, Peter, for pulling, what the runtime handler is going to be for the pod that it's being run against. We've already added a couple of other, annotations for the pod information that we're passing down. I think that's going to be a part of this policy thing anyway, going forward. We're gonna need to know what's going on in the pod when we're pulling an image.
Wait, don't we already specify the runtime handler on image pull? Doesn't this happen already?
It might be there. We might have already added it. Yeah. We might have already added it. Yeah.
I'm pretty sure we have this already as a codified CRI field. So actually, I'm back to, I'm not sure the PR is strictly needed because it would, the pull image request. Oh,
where is it in code? I don't think it's there. I don't think it's there. I may be wrong, of course, but I've looked for it.
Well, it wouldn't have been passed as the handler. It would have been passed as the pod spec. There's a pod.
I think it's in the pod create.
Yeah.
Sure.
No, on the image, we're passing something down.
It's on the image pull.
Yeah, so we don't need only for image pull. We also need it for the status, right? To check that it exists. In that case, we don't have the pod spec there. We only have image ref there.
Yeah, we don't specify in status what the runtime handler was, unless it's already in the pod. Maybe it's there. I have to check.
I'm pretty sure it should be in the pod sandbox config for runtime handler.
Okay.
How else would the pod know what runtime handler it is?
Yeah, pull image request has an image spec which has annotations, and then also pod sandbox config, which should have the runtime
It
question.
should have that handler. Yep, there you go.
So the situation that this, sorry, there's just the situation that your PR would be optimizing for is for if the kubelet didn't know, like, if it didn't know that the pod sandbox was going to be run in a separate runtime handler, pulled the image, but then it actually was, which I don't think. So I think the risk is like only for the duplicated case where the pod is first run in the default runtime handler, so it's not pulled into for that specific handler, and then later the same pod
Right.
or the same container is being pulled for that. But I think that that's fine. So I'm back to, I don't know if we need the PR as is. I don't think we need
We might
the
need a little
annotation.
bit of
So
code
this-
in there to determine is present based on the handler information as well in the image status. We might need a different line of code or two.
But that
Yes,
should be up
so
to container D to report.
So Peter, the scenario described is exactly what we're trying to address here. Is when you first run in one handler, and then you want to run the same image on a different handler. At the moment, it fails.
Oh,
right?
okay.
And this is
Oh,
not,
it just straight up failed.
Yeah, and the reason it
So-
fails is because in the image status, we don't know what the sandbox is. The pod sandbox is not there, right? So it's not something that we can check. Right. So in the pull
Yeah.
image, it is there, yes, but the status, which is used to check if for the presence of the image, it's not present. So we don't have the information there.
I see.
So
So
is it-
I was saying what I was saying based on the hearing that container D was pulling the image for the container create if it wasn't present in the runtime handler that it was, is being created in. If that's not the case, I could see this PR fixing it, but I kind of feel like maybe that's a container D implementation detail that needs to be fixed instead. Like,
It could also be a timing issue. I need to look
Yeah.
at it.
I think
If they get a timeout, Peter, because they, didn't expect the start to take so long, hint, right? They may be getting a context timeout while we're
What
still
we're getting-
pulling the image.
No, what we're getting is not context timeout. It's actually, you're trying to create a snapshot. You're trying to prepare a snapshot, and the parent is something that doesn't exist, right? So like you believe that the image is present, and then you're trying to prepare a snapshot to be able to use that, right? It's a different error. It's not a timeout.
Oh, okay.
yeah, so that
probably
that
not
needs to be
notation.
That's a pull request required in the cry code than in the plugin. Let's talk offline and get the fix in on in the plugin.
yeah,
In the
that
cry
sounds like a
plugin.
container D.
Yeah, we also may want to have image list CRI API improved so we know which runtime handlers it's registered on.
Yeah, we need that. Yep.
Wait,
And
so
if we have
so
that, then
I
maybe we don't need kubelet to pass anything specific.
for my own understanding, you suggested that we should change containerd to pull the image. But is containerd aware of the policy, right? The policy could say never pull, for example, or it could say actually never pulls is the case when this
That policy is not passed to container D yet.
Yeah, so if containerd doesn't know about the policy, then it wouldn't honor it, right?
Correct.
So
Yeah.
so the policy
It's a
could
little,
say
that's a
never
little
pull.
weird. Yeah.
The policy
Wait,
would say
there is
never pull.
there is a never pull flag passed in. Hold on. Isn't let's look at the code in detail offline and talk about it. The flag may be pulled, may be passed to not pull.
No, I
already.
don't. I think you're right. I think it wouldn't be passed down because the kubelet's the one triggering it based on that field. So I flipped again back to your PR sounds useful for that reason. Yes. So thanks for workshopping this. I agree, because yeah, container, or the CRI isn't aware of pull policy, and so the kubelet has to be able to tell it when to pull and when not. So like if the update is always and the container is being run again, containerd wouldn't necessarily know to re-pull the image if it was already, if the image was pulled in the default runtime, but not in the non-default one. So yes, +1
Yeah,
for
that
me.
makes sense. I got a vague memory, Peter. I got to look at the code, but I have a vague memory that kubelet does tell us when they run the pod in some spec policy there that never pull. Local only kind of thing, not allowed to pull the image or update it. I'll check.
Sasha, you wanted to do some comment? Okay.
Yeah, I wrote in the chat.
No, and I agree with you, Alexander. I think down the road we definitely need to get this pull policy to be passed and the runtime handler in a more formal way, with under the expectation that the container runtime is going to be managing the images, collecting them and such, which would require kubelet to also pass down the percentage of resource use policy so they can do that collection, right? Remove those images as well, right?
Yeah, I think I would vote we table that conversation for 129 when we begin rethinking what image eviction looks like in the kubelet, which we had talked about doing already.
Okay, sounds good. All right.
And one more comment, if you can validate that we don't break any backward compatibility issues. If customers has same snapshot for different runtimes, it should continue working as is. We shouldn't be breaking these scenarios.
Yes.
Okay.
We have tests for that. Yeah.
Okay, let's go with the next item. Is Mohammed?
Hi there. Yeah, can you hear me?
Yes.
Yeah, sorry about that. I was a bit late earlier. So yeah, as you may or may not have heard lately, we've started running some Node E2E tests on AWS. I've been working with Dims and Todd on that for some time. There is an opportunity to take another look at how we do SIG Node E2E tests for nodes in particular initially. Given that we have a fun requirement where we need to run a test scenario against many operating systems and now multiple architectures. And I see that the COPS project has a neat way of generating what's effectively a test grid of various permutations. So I had a look at how they've done it. So they've got this little Python script in the same folders as the power jobs, and they basically define a test scenario running against, let's say, 10 OSs with multiple options, and then they would generate a power job. So they've probably got hundreds of jobs generated like that instead of a human writing all those jobs out. So I have a PR in there that implements that. So it'd be great if you could get that approved. I also want to take this opportunity to finish that KEP that was migrating to Keep Test 2. And then there's a lot of, most of these legacy jobs are using Bootstrap. We need to get rid of that too. So if you, the big long file there, look at SIG Node grid real quick.
Okay, so is it just awareness or?
No, I'm starting that work. I need some people to start approving things. I need to finish that PR, but this is kind of what I wanted to let the wider group know. That's what I'm working on. Initially, these will be CI jobs. Once the jobs are stable, we should probably have a conversation about picking which ones you want to use as permanent pre-submits.
Okay. in the CI group, we discussed recently what Dixie wrote a document about permutations we want to test. So maybe it's a good opportunity to talk together and
I mean, the meetings on Wednesdays, right? Every week.
Yeah.
Yeah, I won't be here for this one, but I'm going to join the next one and have a look at what was discussed before and see what I'm working on and where they're at. Someone else was having a conversation about ARM64. They wrote something. So I'm probably going to talk to that person as well and see where we're at.
Okay. Yeah, I think Ike was involved and somebody else, I don't remember the name. Okay. So yeah, welcome to CI meeting. We have a document linked one of the past meetings. Dixie, I see you on a call. Can you add link to the document in the agenda?
Sure, I'll do that.
Thank you. Yeah, and probably we'll start converting it into PR and discuss everything on GitHub as well. Thank you for bringing it in. Okay, next topic is Francesca.
Hello. So, okay, it's about one issue which was open a few weeks ago, and it's fixed. So I'm trying to get basically design review and code review, and just trying to bring attention because it's a regression. So a bit of context about this. A while ago, we had a bug on which we noticed that the device were improperly handled on node reboot. Basically, what happened, it was on node reboot and the pod were admitted, and because our code worked, the workload was started without the device actually allocated, which in some cases is very bad, and we fixed that. Unfortunately, for reasons that are explained in the PR, but basically boils down to few issues in the tests. We introduced there is now a regression in which kubelet restart causes pod actually yes container, but still pod kill on kubelet restart only for container consuming devices, which is of course bad and which was of course want to fix. So this is it, and basically I think I found a fix thanks to a conversation with Clayton and others. Others in this group already commented on Slack. Thank you for that. And I think I found a way forward which should make everyone happy and should address all the questions I'm aware of. But I will really love to have more comments and review and confirmation or not that this is indeed a good way, or any missing items. And so this is me asking for that. So if anyone question or comment, I'm happy to answer. That's why feel free to catch me on Slack.
Francesca, try to contact Evan Lizar from NVIDIA. So besides Kevin, he might also want to look at this particular thing.
Yeah, Kevin is tagged and I pinged him on Slack, but Evan is a good suggestion. Thank you for that. I will get in touch.
Yeah, I just wanted to mention I also spent a little bit of time looking at this and have a few comments. I'll send them out on the PR. But big thanks for working on this. I think overall it's definitely right fix and looks good to me overall. Just a few kind of small comments I'll leave on the PR.
That's very welcome, David. Thank you very much.
Yeah, it's yet another situation when kubelet restarts shouldn't be that dramatic. I think another problem we have is with probes, right? When kubelet restarts, it makes everything unready, and then we need to reprobe everything. It's much smaller problem though, but still similar aspect of it.
Yeah, this area about kubelet restart is, let's say, we can probably improve a bit overall. So there are a few dark corners, I would say. So let's make it more robust over in the long run. Thank you all.
Peter?
Yeah, so this one, I just wanted to bring up some light complications that have come up about the C group driver thing that are not insurmountable, but I just wanted to bring it to the group's attention and gather feedback. Basically that, currently the idea is for the C group driver field to be static, in that the kubelet requests it once and then assumes it to be the case. But technically speaking, the CRI implementation can reboot underneath the kubelet and change that value. So I just wanted to make people aware of or discuss, like, what I'm imagining for it is adding a caveat in the CRI spec that says if the C group driver is changed, then either the CRI should ensure that there are no containers running currently, like it hasn't restored into containers that were previously running on the last run, or the node like has rebooted. But that is something that has to be enforced on the CRI side, because the kubelet is not going to be continually asking for this field, so it won't be able to learn that it's changed and react to it. So, we definitely have precedent of asking the CRI nicely to do things, but I just wanted to double check that approach makes sense to people, and they don't have any concerns or anything.
So the kubelet will ask a customer to clean up everything before change, or kubelet will do something? I didn't get it. Kubelet.
So the problematic behavior will be that the kubelet. So if the CRI changes the C group driver underneath the kubelet will not be aware and will continue to create the old, whatever the original hierarchy is. So like if it's originally system D, kubelet will continue to create slices for a container that will now like not be managed by system D. So I assume, I haven't tested it, but I would be surprised if that worked. I know Cryo like manually checks the paths of the pod C group to check that it conforms to what it expects to be the C group driver. I don't know if Containerd does the same, but I assume that the container creations or pod creations would start failing because the pod C group and the container C groups are like different drivers. So the expectation that is being declared at the CRI spec level is that this is the responsibility of the CRI implementation to handle gracefully. And a couple of ways that could happen is either it ensures or basically it needs to ensure that there are no running containers when the C group driver switches. Because the kubelet would have already created the C group hierarchy if there are already containers, and so we basically need to make sure that the switch doesn't happen mid-run of a node. The easiest way to ensure it is just node reboot, and it needs to go along with the node reboot, which would be possible to check, but might be a little bit more complicated than just checking if there are any running containers.
Okay, so in a restart situation, you want us to confirm that no existing chems are running under a different C group, and if they are,
right,
we need to warn or error on the reboot and ask them to reset it to the original C group, and then so that they can shut it down, right? And
yeah,
in the config, we need to highlight that any change to this needs to be acquiesced first, and then before you restart.
Exactly. Yeah.
So no dynamic reconnects on, at least on C group.
Right.
Or kubelet has a list of already running containers, and it knows where the C groups which was created, so it can just go and restart.
But it won't detect. But it doesn't know when the C group driver has been changed, because it's not. I mean, if it would know if it itself was restarted, like if kubelet restarts, learns a new C group driver, then the other, like the pods that it's able to find, like that could happen. But I think it would be better if we just declared that the CRI should not change the C group driver if there are any running containers. So if the CRI implementation restarts and the node hasn't rebooted or the containers haven't been removed, then and the C group driver has switched, then the CRI should like error or like return a response to the kubelet or so. Like it should, that's an error condition that should be handled as abnormal, because it would otherwise make like some nefarious errors happen during container creation that might be confusing.
Thanks,
confusing
yeah, 'cause I was really wondering. I was wondering what we do on this on a reconnect. Would they call this stat give me the static config again on every reconnect?
Yeah.
Sounds like the
and
answer is
I don't
no.
think we should set that. No, I don't think we should. I don't think the kubelet should be in the business of trying to figure out if the CRI implementation changed it. I think we should just make it clear the CRI is responsible for this, and it needs to be smart about when it switches.
Okay. And we'll put that in the CRI API, in the new API. We'll just say this is only
Exactly. I wrote a note
on the reboot of kubelet that this would happen. Okay.
Yeah. So I put some notes in the CRI spec in this PR. I'm taking it over from Marcus because he's on vacation. So please take a look and let me know if it's clear enough. I'd be happy to fill it out more. Or yeah. So cool. It sounds like we're in agreement.
Please acquiesce. I like it.
Yeah.
Thanks.
Cool.
I had one question about the proposal as well. I'm not sure if it was covered somewhere else, but like, I don't know how big of an issue it is, but for different runtime classes, is there a different C group driver potentially per runtime class, or are you making an assumption that all classes will have the same C group driver?
We're not supporting that in Kubernetes. I think we previously briefly talked about it, but basically, because the kubelet is managing the hierarchy itself and is managing QoS classes, for that, it would make it really complicated to try to manage it between different ones. So far, we've just not even tried to support that, even though Containerd supports it. And I think that we should continue doing that.
Gotcha. Okay.
So
Yeah.
guys, literally at the host level.
Makes sense.
Yeah, it would create it would make the kubelet code a lot more complicated. If we move to a world where the CRI is fully in control of the C group hierarchy, then maybe, but at that point it would be an implementation detail of the CRI. But I don't think we should teach the kubelet how to multiplex the CRI, the C group driver.
Makes sense. I think that's fine. My only concern is if there's someone already doing some crazy stuff like that. I don't know if someone's using, say systemd C group driver on the kubelet pod level C groups, and for the container ones, maybe they're running inside some VM or something using C group driver. I don't know if this is something anyone does. I just want to make sure we don't affect their use case. I personally, I'm not aware for basic, use cases, or even like gvisor, for example. I'm aware it has, it has to match, but I don't know if there's some other weird runtimes that have some special rules. I'm not aware of any, but just wanted to ask. Well, and
admittedly, there are some hacky situations that some cryo code has where systemd doesn't manage certain C group fields, so cryo will manage it on its own. But that said, we're not teaching the kubelet about that. So if that creates any weird situations, that's the CRI implementation's fault, and it's not something that we should make the kubelet aware of.
Makes sense.
David, it's more weird situation when kubelet goes and tries to change something directly in the C group versus what it's supposed to be done in runtime. Trying to assume some location of a container level C group where the container is run inside VM.
Yeah, that's a valid point.
Yeah, but kubelet does have that boundary pretty strict about just managing the pod C groups. So this is not yet an issue, but yes, that could be something that comes up. But yeah, I think that is a good question and a point that was brought up, David, but we're not worrying about that.
I think a related issue was long-standing problems that I found another day is the fully drained node problem, when we cannot ensure that we fully drained all the containers and all the pods from a node. But I don't think we want to solve this problem as part of this effort, right?
How is that related to the C group?
No, it's not about C groups. It's about a previous issue about driver. We need to drain everything before switching driver.
Yeah. And I mean, we can't do any guarantee of that in the kubelet, I think, but we can, that's why I feel as though it should just be the CRI's responsibility to ensure that the state transitions make sense.
Okay. Yeah, we are at the end of our agenda, and we have only 5 minutes left. Is there anything else somebody wants to add? If no, then happy rest of your day, and bye-bye. See you next week.
Thanks. Bye-bye.